Hello everyone, a very good morning to all of you. I welcome you all on behalf of Solar Quarter and First You Group in today's webinar on Egypt Solar Technology and Innovations Roadmap. Thank you to all our esteemed guest speakers and the attendees for their valuable presence in today's webinar. Your active participation has contributed to making this event truly remarkable. In 2023, Egypt's solar industry is set for more growth. Key reasons include the region's dedication to clean energy and cutting carbon emissions. Plus, hosting Egypt's Solar Technology and Innovation Roadmap in 2023, Egypt will spotlight renewable energy, possibly leading to more investments and changes for development. It also gives me immense pleasure to announce that we are coming to Cairo on 23rd October. Please mark the dates 23rd October with our physical event, the Solar Week Egypt 2023 Conference and Awards Physical Conference. And we invite you all to join us for an informative and engaging experience at this event. The registration link for the same has been added on the chat box on the right side of your screens. So, without any further ado, let us begin the show with today's keynote address. We welcome Ms. Amin Adil, who is the sustainable energy expert from Renewable Center for Renewable Energy and Efficiency, to share her insights. Welcome on the screen, ma'am. Please take it ahead.
Thank you so much, Pandy. It's my honor actually to be here with you today. Good morning, everyone. I would love at the beginning to thank you for being with us. My name is Engineer Iman Adel. I am sustainable energy expert at the Regional Center for Renewable Energy and Energy Efficiency, which is dealing with 17 member states strategically in terms of renewable energy and climate change. At the beginning, I would love to highlight the importance of this gathering in the context of Solar Week in Egypt. During such webinars, we can usually discuss further the challenges facing the solar technologies and innovative methods to enhance, promote, and catalyze it, given the difficult economic context facing the world and the sustainability concerns within the decade. Actually, the sustainability and renewable energy is a vital issue for the MENA region countries facing a range of economic, social, and environmental challenges, such as the increased energy consumption and production and a rise climate waste management associated with rapid urbanization, population growth, and biodiversity loss. For that, the transition to renewable energy require significant infrastructure development, and this includes the construction of renewable power plants, the modernization and expansion of transmission and distribution network, and the development of energy storage solution. With the scale of complexity of these infrastructure projects challenging in terms of financing, in terms of planning and coordination. In addition, the high upfront cost of renewable energy projects, coupled with the economic uncertainty in the region. One of the main challenges also is integrating intermittent renewable energy sources into existing grids, as the nature of renewable energy generation require grid enhancement and the development of a smart grid infrastructure, which represent ensuring the stability and reliability of the grid, while absorbing the variable renewable energy sources. Noting that the MENA region countries need to develop clear and consistent policies that support renewable energy deployment, energy efficiency, and grid integration. This includes setting targets, implementing supporting systems, and provide incentives for investment in renewable energies. The continued expansion of the renewable market, in particular, has been a bright spot and the only segment of energy market to experience notable growth even during the past few years of global crisis, building on its cost effectiveness and strategic value for increasingly carbon constrained economics. Despite this trend, the protracted nature of socioeconomic impacts from the COVID-19 crisis and the global implication of the war in Ukraine and continued economic uncertainty generated by both, bringing risk to the clean energy transition with potential barriers in foreign investment, public budgets, and private finance in renewable energy sector. In the MENA region, counting a momentum on the energy transition can build on the success countries have achieved in recent years since the last major economic crisis of 2008 and the uprising of 2011. Many countries has expanded renewable energy investment as part of their recovery strategy. Solar and wind capacities rose to tenfold in the decade that followed, from a combined capacity of around zero point 0.5 gigawatts in 2008 to about 7.2 gigawatt by 2018 and continued their increase in 2019. Furthermore, still only about 7% of overall energy today remain from renewable energy and only 1 to 2% from solar and wind. Thus, despite the region's position as the largest solar radiation region, capacities for capitalization on these strategic assets are still in many ways at a nascent stage, but the upward improvement over the past decade offers a base for which to build a more ambitious energy transition in the coming years. Countries on the region have set a cumulative target of about 190 gigawatt of renewable energy capacity by 2035, which is expected to account for as much as 30% of the global gross in renewable energy. And an important foundation for achieving this dramatic expansion will be the National Renewable Energy Action Plans enacted in recent years and related institutional and financing system to implement them. As seen in the upcoming panelist and their discussion across the region, we could discuss together the targets and innovative policies from the base of attracting private investment, reforming energy subsidy, and establishing renewable energy institutions and energy development zones. At the end, I would love to highlight how it's necessary to keep discussing in such events as it brings together various parties to create a platform for cooperation, knowledge sharing, and exchange of best practices to ensure continuity, promote innovation, and ensure sustainability progress toward common goals in the field of energy and beyond. And finally, the Regional Center for Renewable Energy and Energy Efficiency is committed to continuing its mission of supporting our 17 member states in accelerating their energy transition and engaging the private sector in participating in such sustainable energy projects in the MENA region in cooperation with our strategic partners as the League of Arab States, the UNESCO, UN Environment, governmental institutions at our 17 member states, Millionaire, and all of our private partners and social banks. I thank you so much, and I leave the floor to my colleague.
Thank you so much, ma'am, for the wonderful insights. So, let us begin with our panel discussion now and allow me to introduce the elite panel for today. Mr. Yahi Abdunor from JA Solar, Mr. Vincent Liu from Hizhao Lapting Technology, Mr. Hutafia Farah from Sofar Solar, Mr. Tamer George from GridTech Infrastructure Company, Mr. Ayman Faik from Aqua Power, Mr. Mohammed El Hadid from IRSC for Renewable Energy Solutions. So, I would like to hand it over to our moderator for today, Mr. Hossein Alam, who is from the Qidad Center for Environment and Development for the Arab region and Europe. So, over to you, sir. I would just like to make a small announcement. Attendees can post their questions in the Q&A box and a speaker will answer those questions at the end of the panel discussion. Without any further ado, let us initiate our much awaited panel discussion session. Over to you, Mr. Hossam. Please take it ahead.
Thank you very much. First of all, I would like to thank you for inviting me to moderate such wonderful panel with very important panelists that I believe all the audience will get benefit from their experience and knowledge in this sector. We have key discussion topics. Advancement in photovoltaic technology and efficiency enhancement, the role of energy storage solutions in optimizing solar energy use, integration of smart grids and microgrids in Egypt's solar energy infrastructure, AI-driven predictive maintenance for solar assets in Egypt, digitalization and data analytics in optimizing solar energy operations, key innovations driving utility scale solar projects in Egypt. Of course, we have 10 minutes only for every panelist. So I will provide the floor for every panelist to provide us with his knowledge and experience. And I will allow every panelist to first introduce himself, his background, the organization or company that he's working for. I hope that we had more time to get more benefit, but this is the reality. We have 1 hour for our panel discussion. Maybe we gain 4 minutes from Ms. Iman's presentation. So please, I would like to introduce or to invite Mr. Yahi Abdenoor, Technical and Marketing Manager, JA Solar, to provide his insights. Thank you.
Thank you, Mr. Hussam. Thank you for the organization and the moderation of the event. It's my pleasure to be with you and to contribute in this webinar with regarding the advancement in photovoltaic technology and efficiency enhancement. I'm Dr. Abdenoor Yahi, Technical and Marketing Manager for North Africa and French-speaking countries, working with GA Solar. GA Solar is the top 4 PV manufacturer with more than 150 gigawatt installed power and more than 90 gigawatt production capacity. So my contribution will be for the advancement in photovoltaic technology and efficiency enhancement. There have been many advancements in photovoltaic technology and efficiency enhancement in recent years. Some of the most notable advancements include, first, for example, new materials. So researchers are developing new materials that are more efficient and converting sunlight into electricity. For example, we have the perovskite solar cells have the potential to achieve efficiency of over 30%, which is significantly higher than the efficiency of traditional solar silicon. So the second point regarding the advancement is improved cell design. So the PV manufacturer, research and development teams are also developing new solar cell design that are more efficient with better performance and better lifetime. For example, we can introduce 3 advanced technology. We have the TOPCon, which is a tunnel oxide passivated contact. It's expected to reach 25.9% in mass production by the end of the next year. The HGT, which is heterojunction, it's expected to reach 26.3% in mass production by the end of the year. And the IBC, which is interdigitated back contact, it's expected to reach 26.7% by the end of the year. So the third point in advancing photovoltaic is manufacturing advancement. So manufacturing advancement have also helped to improve the efficiency and cost of solar cell. For example, the production process technology that to move from a technology to another one. For example, moving from PERC technology to TOPCon technology. Development in manufacturing process allows us to produce high efficiency solar cell at low cost. Also, the size of solar cell is one of the factors that affects its efficiency. Larger solar cell tend to be more efficient than a smaller one. So the manufacturers are moving from a standard square cell with 1A2 by 1A2 millimeter to a rectangular cell like 1A2 by 188 or 1A2 by 199 or 1A2 by 210 millimeters to upgrade the module power. So as a result of this advancement, the efficiency of solar cell has significantly in recent years. So discussing about GA solar, for example, the highest efficiency solar cell now have an efficiency of over 25.6% for TOPCon technology. So this means that this cell can cover over 25.6% of the sunlight that hits them into electricity. So this advancement in photovoltaic technology and efficiency enhancement are making solar energy more viable and more affordable option for generating electricity as solar energy become more mainstream, and it's expected to play an increasingly important role in meeting the world's growing energy needs. Thank you.
Thank you, Mr. Yahya, for this valuable information. As you raised, the cost issue is a very important issue in the development of such new systems, and technology that's needed for this is very crucial. I will go now to Mr. Vincent Liu, Sales Director overseas excuse me, Hazuli lifting technology. Mr. Vincent, the floor is yours.
Hi, hello everyone. This is Vincent from Lipton Technology. And Lipton is doing a robot for solar. And currently from the market, I think everybody in the solar, maybe they already know that from the solar market, people are using a robotic cleaning system. While the cleaning system currently, we are facing a lot of maybe the issues. We can see the manpower, the labels, the job loading is quite a lot. So we are doing is to do more artificial intelligence robots to support the solar panels cleaning, and as well further to go with the innovations with more AI intelligence equipment for the module installation. As Yahi from JA Solar was mentioned, that the module dimensions are actually increasing, and now for manually installing the modules, actually it was quite difficult because the module panels are getting bigger. So for the solar market, we are now considering about the major equipment, inverter, module, or the cables, or the structures. And the major part from the inverter, we are considering now the intelligence, the artificial intelligence, which is quite important for the analysis, the calculation, and generations, which are combined with the AI, is quite important, and it's increasing the efficiency of the power plant. And further, how to do the O&M in also in the artificial intelligence side is an important thing, because we have to handle the O&M for this side. For people are saying 25 years, but actually the worldwide, the oldest site is more than 40 years, and it is also running at the 70% of the established capacity. So we are considering that the innovation of the O&M is quite important. And as well, because of people are also considering the carbon emission for all the solar process, the industry. So we also need to consider about the innovations for the power plant from the beginning. For example, the construction stage, and then to the commission. and then the O&M is also important. So AI intelligence could be implemented to all the process of the solar industry. That's what I'm thinking about. Thank you.
Yes, thank you, Mr. Vincent. I believe your system will provide better efficiency for the plants. This is what we totally needed. That the investment can provide the maximum output of energy that can be generated. Uh, I think now I will ask Mr. Huzaifa Farah,
Yes,
sales
thank
manager
you.
from Middle East, so far Solar. The floor is yours.
Thank you. Thank you, Mr. Hussam. Thank you for your kindness and handling this presentation and your support for this. Well, I'm welcoming everybody here in webinar. I am Hudayfa Farah, sales manager, sales manager for Sofar Solar inverter and ESS storage system provider established in 2013, and we manufacture first inverter in 2014, and in 2016 we produced first energy storage inverter. In 2017 reached top 5 string inverter enterprise in China. In 2019 we entered the global market, and we one of the top brand by AUPD, and in 2023, we established ESS utility system, including all the storage for residential, commercial, industrial, and utility. We have more than 500 R&D staffs and 100 plus patent and 3 R&D center over the world. We are providing efficient and reliable DC to DC and DC to AC power conversion, grid applicability, grid support, and other grid interaction technologies, rapid fault diagnosis technology. We have more than 20 global offices. We will discuss now about the benefit of the storage since it's needed in the Egypt market. It will be applicable for residential and commercial, industrial, and utility. For the residential product, main application we can using for the storage systems is self-consumption, maximizing the utilization of the PV resources, peak load shifting, reducing electricity cost of a grid application, also ensuring reliable power supply to critical load. Designed for rooftop and backyard power stations. The system support including full grid connection, disconnection, all the consumption modes that needed for residential application. This the same will be applicable also for commercial and industrial, for a peak load shifting and emergency power in order to ensure reliable electricity consumption and improve ROI of the owner. For commercial industrial, we have sizes starting from 3 kilo up to 200 kilo for one single system. Also for commercial, we're providing high efficiency, power generation, safe and reliable, intelligent and easy to use. Also, for a PESS solution for utility product, it's compatible with PV, wind, thermal power system, a new energy utilization, power output smoothing, peak shifting, frequency regulation, and peak load leveling, and also providing all auxiliary services to the power grid. It's widely used in power generation, transmission, distribution, and utilization. High efficiency power generation, safe and reliable, intelligent, and easy to use. This will provide end user less LCOS and high efficiency, flexibility, ultimate security, and intelligent stability for all the storage system for residential, commercial, and utility. This is as a brief about the benefit of hybrid and battery system, storage system that you will use in the market, since there is a huge demand for the power, some disconnection in some areas. This will increase the demand for storage system with multi-applicable. Mr. Hussam.
Thank you very much for this information. I believe will at the question and answer you'll find a lot of questions. As I anticipate, now we are going to ask Mr. Tamer George, Group COO, Greatest Infrastructure Company, to have the floor. Mr. Tamer. I can't hear you. Mr.
Mr. Temer, we are not able to hear you. Can you try to rejoin? By the time, Mr. Hosam, you can move ahead with other panelists.
Yes. Okay. Now I will ask Mr. Ayman Faye, Senior Manager Business Development, Aqua Power, to provide his insights and speech. Mr. Ayman, the
Thank
floor is
you,
yours.
Hussam. Thank you, Hussam. It's a pleasure to be a part of this event. Let's introduce myself. Ayman Faye, Senior Business Development Manager, working with Aquapar since 2015. If we're talking about a short speech about Aquapower International, KSA co-founders for Aquapower have it 77 assets with total capacity of the energy 50.4 giga install, 6.3 million meter cubic distilled waters per day, total assets $78.2 billion. The share of the renewable energy coming like 16%, aiming to 46% up to 2030. If we going to the main topic, which talking about the solar energy worldwide, I bring some of the numbers to just to highlight it, the important PV technology. If we're talking about the current situation in the world in the report, estimated and calculation report, talking about 2018 from IRENA issues, talk about total install up to this moment around 500 gigawatt. The aiming to crossing the decarbonizations and to be the rule of the solar panel and solar technology. It's something like going through up to 2023, something like additional adding 284 gigawatt, reaching to 2050, it's something like 8,500 giga of the PV install. That's mean it can be from the calculation of environmental impact, something like to reduce the emission, CO2 emission, something 5 gigatons at these times. Concerning the an Egyptian market, if we talk about Egypt, the total capacity in Egypt something around 60 giga install, 8% of renewable energy, total solar share 27% of the total capacity, total energy generation. Also, we would like to mention for the progress in the Egyptian market for the solar energy. When we took from the point of the developer is coming for the last call during the COP27 for the green hydrogen projects. more than 23 MOUs has been signed. Some of them convert to framework agreement, and the total expectations for renewable energy to be feed the system, something the total numbers 101 gigawatt totally, 35 from the solar, 66 from the wind, to feed the electrolyzer, around 44 giga installed from electrolyzer. That's mean it is Egypt. It will be the promising marketing for development the solar energy. If we talk about the real situation now in Bimban, in Egypt, we have it 1.5 giga installed in Bimban since 2019. We have an honor to have 120 mega in operation and another 200 mega PV under construction now in Komombo. If we're talking about the maintenance and predictive maintenance, and to take the rule of the artificial intelligence. If we talk about this scope or this topic, we can elaborate it. Some of benefits can be achieved from the intelligent applications. We aim to reduce the downtime. We aim to cost saving, increasing equipment lifetime span, enhancing safety, and assets optimization. How to focus or how to be elaborated more practically. Aquapower, it's owing some trial, and now we have working with a software, intelligent software, just to collecting all of the information coming from the SCADA system, putting in one analysis software, just to monitoring the system and predict all of the problem can be raised, and to be improved our operation and maintenance. So it can be in one screen. We can have the radiations, total power generation, panel temperatures, wind speed, and also can indicate it about the time factor for the inverter itself. So according the inverter and clocks, which part of the system, can be follow up what the critical equipment can needed to some intervene or some corrective actions to use it. So the artificial intelligent software, it could be one of the director to improving the economic scale for the project, and to achieve the operation maintenance for 25 years. This is a total number which can be shared with these sessions, and we are welcome to any questions to be answered later. Thank you.
Thank you, Mr. Ayman, for this informative information. I believe after we finish, we need to have more information about the efficiency of the green hydrogen produced by solar energy. So maybe Mr. Tamer, are you back and
Yeah,
available?
so now you can hear me.
Yes.
Yeah,
Yes.
perfect.
Please, you have the floor. Please introduce yourself and provide your insights. Thank you.
Yeah, thank you so much for, first of all, Mr. Hussam, for such a lovely discussion. I believe that everyone was a reason for having such an event. Should be thankful to have such a fruitful information about the solar future. So this is Tamer George. I am the COO group for GradTech. GradTech, we are an EPC and installer company. We have our head office is in Mauritius. We are existing across 7 countries in Africa. We are honored to have more than 275 megawatt already between operating and ongoing operation. across the region. We have our UAE office, which taking care about the GCC countries, especially in solar projects. And I would like to speak a little bit about the artificial intelligence and maintenance, where in our region comparing to Europe. I believe that the artificial intelligence is something very important for all sectors, especially when it comes to the solar. It can save a lot of time, it can save a lot of OPEX and CAPEX when it's implemented for the operation and maintenance. Such robots would have been presented previously, and such kind of high-tech solutions to make the preventive maintenance can take place for saving a lot of time and detecting the fault is on spot, rather than I believe that it will take a little bit of some time to implement such such kind of technology in our region. As we go, we are having the rural area where we are counting more about the manpower, especially with the local community for the rural area in Africa and rural countries and rural areas in Middle East country. I believe that it's more significant to give them the awareness of the ownership for such a PV first, and then we can start to implement the AI. I believe, yes, 100% that the artificial intelligence can take a place where we can get use about saving a lot of OPEX rather than in the future. However, we can as well having a lot of a lot of tools where we can use it, like all projects, regardless the size and the experience, average annual O&M cost escalation have on various cost factors. Especially for the utility scale projects, we have the cost of escalation, the site operation schedule, and the market is highly labor cost. So the cost escalation has been a profound impact of the ability to provide and maintain competitive and must do through the operation improvement. I believe that BIM, building information modeling components, is a dynamic way, keeping up to date the maintenance tickets and reducing reducing the maintenance tickets, configuring a challenge and sensor measurements and control signals, which get the benefits of monitoring and optimizing the whole plant performance. Additional BIM can serve an ideal database insights regarding, among others, components. Also, the aerial 3D modeling process allow very accurate representation for solar assets. The 3D modeling also cover the ground topology and everything like tree shading, buildings within the site. Allowing the 3D data is a cost-effective way, helping us to overcome a few challenges like the as-built CAD, including like the pitch atmos, the tilt, the incorrect, accurate absence, the shading scenes, and the inaccurate of the trees have grown. So the accurate 3D model of the site required period of maintenance work and electrical simulation, example in the PVCs, is based on incorrect and poor assumption for the layout topology. The BIM and O&M during the O&M phase, BIM methodology can help identify individual components, tracking their performance history, and possible helping effective maintenance. Also, for regarding the role for the storage battery, it's optimizing energy storage system, ensuring the grid stability and on-demand availability, preventing the blackouts, and they're essential in modern grids, smart grids. I believe that energy storage is something where all the content right now is taken care of, where yes, the technologies already get advanced in terms of the module, the inverters, and the trackers, and everyone right now is looking after the storage and the energy storage grid. I believe that the benefits it's get the grid stability by smoothing out the fluctuation and the renewable energy generation, and it store excess energy during high production period and release it during the low production period, maintaining constant power and supply and reducing the risk of the grid disturbance. And thank you so much.
Thank you, Mr. Tamer, for this informative information. I think our last panelist, Mr. Mohammed Al Haddad, Head of Energy Department, IRSC, for Renewable Energy Solutions. I think we're good on time, so if you would like to have more time for your insights, you're most welcome. Please introduce yourself, background, and your company, and what would like to tell us today.
Thank you.
So the sound is not clear. I don't know if this is a problem with.
I will
Mr. Mohammed, we are not able to hear you. I believe you have some technical problem. Can you switch off your camera and keep your mic on? Maybe that will work. Mr. Mohammed, are you able to hear me? No, your voice is a little muffled up. Can you switch off your camera and then speak? Maybe that will help.
Mr. Hassan.
The sound is not clear, Mr. Mohammed, at all.
Okay, can you hear me right now?
Now it's better.
Okay, it's maybe a problem with the AirPod. Okay, let me start to introduce myself first. This is Mohammed Al Haddad, Head of Energy Department in ERSIC for Renewable Energy Solutions. ERSIC is considered as a full EPC operator specialized in solar energy projects. Established back in 2011 as one of the first certified renewable energy companies in Egypt. And across this period, we were succeed to implement more than 50 megawatts of installed capacity, with a number of remarkable and first to implement projects. As of back of 2020, we succeeded to finalize and construct the first private-to-private sector PPA project. And within the scope, we were succeeded to finalize at 10 megawatt between the construction and the engineering activities. And right now, we are establishing the first mega project for the petroleum sector, which is amounted of 14 megawatt. I will start directly with AI, but my point here will not be just for the means that AI will be needed to be done during the commissioning of the PV plant itself, and also after that during the operation and maintenance. We have to implement the AI in a part in intelligent and centralized control centers, in which the grid stability is a must to be checked before the connection. So a number of sensors and devices must be implemented in order to connect or start the commissioning process of the PV plant itself. Based on these sensors and devices, we already are going to be able to collect a huge amount of data, which will facilitate the interconnection of the PV generated power along with the smooth flow between the grid itself and the PV systems load flow. Going forward for the O&M part, it's essential to have an AI in something called an asset performance management, in which we started with data collection and integration. This part is mainly concerned with collecting all the data and put it all together. If you are talking about the weather forecast, historical performance, sensor readings, the manuals of the equipment itself, the PV simulations, and all of that must be unified and collected in one single repository. Then we doing something called the data processing. Data processing, all the algorithm, all the, like we can say, the thinking. Then engineering or the engineering here, when like we can say here, we can implement the AI algorithm itself in order to
Mr. Muhammad, sorry for interruption, but can you turn off your camera? Maybe because it seems the bandwidth cannot hear you very well.
Yeah. Okay. Continuing in the feature engineering, like we can say that we are implementing the AI algorithm itself, where we are adding all the actions that needs to be done and also when to do it. So we are building something like an events planning itself and the actions related to this events planning. And last, in the part related to creating the asset performance management platform, is having a predictive analysis, which mainly can be done by using the drone-based inspections. This is aerial thermographic inspections that can have a full detailed inspection and status of the current existing working equipment and material inside the field. Actually, one of the best things that AI can already provide is that it can predict the lifespan of the equipment and checking for its percentage of failure. So if we are, for example, having something like a hotspot on a PV module, it provides us with a percentage of how deep this error is gonna affect us. And this is gonna be reflected back to the risk assessment itself and checking for the integrity, if you are gonna repair or replace or remain everything as it is, based on the revenue loss or anything related to the system downtime. Going for the preventive maintenance, which is the ordinary normal maintenance, like we can say, AI can help us in predicting all the loss packets that already being done during the operation of the PV plant. For example, soiling losses, the shading, the thermal grid outage, all of this stuff. And this helping us in not to have a normal, mandatory, rigid schedule for maintenance. It can be, like we can say, agile maintenance procedure or schedule that can be optimized in order to reach the best for the PV plant performance. Of course, all of these points coming together, we are reaching an enhanced energy generation and, of course, an accuracy in the numbers that we are having of how much we are implementing and integrating inside the share of the load flow itself and what is the share of the solar energy injection after finalizing all of this huge AI scheme. I think this is it. Thank you very much for your attention. Thank you.
Thank you, Mr. Muhammad, for your insights and view for the discussions. Likely we have finished early, like 11:18, but maybe this is a time to start some questions or discussions. One of the issues that we always presented when we do presentation about sustainability, that resources now on Earth is not enough for everyone. The scientists, they have made a research and said that 2020 we needed 1.7 Earth, like nearly 2 planets, which is, of course is not available. And then by 2050 we need 3 planets. So this will make all countries will start thinking about consumption and production, of course. So we believe solar energy or renewable energies is It's the only solution. This is how we can anticipate it. It's the only solution to be able to sustain the energy requirements of consumption worldwide. One of the issues now that has been raised, of course, as we maybe Mr. Ayman has shed the light on it, provided information about desalination and energy use for desalination and stuff like this, which is very important for green hydrogen. Green hydrogen need fresh water, and we can see that in Egypt now is getting more requests to provide plants for green hydrogen. So maybe there will be major issue for desalination of the water, and this, of course, we need solar or wind energy. So maybe this is another issue that can be any of the panelists would like to add. Mr. Yahi, I can see that you would like to add some points regarding the storage system. Please do. The floor is yours, and then maybe any one of the panelists can provide insights about the issue of using more energy for desalination or more solar systems. Mr. Yahi, the floor is yours.
Yeah, thank you, Mr. Hussam. So I want to add some additional point regarding the point highlighted by Mr. Hudhaifa and Mr. Tamer regarding the energy storage system. So the question is why we are linking the energy storage system to PV system, to solar system. Linked it because the solar energy is intermittent energy, because it's only available when the sun is shining. So it's also variable because the amount of solar energy available depend on the weather conditions. So the energy storage solution can help to address this challenge by storing solar energy when it's available and then discharging it when it's needed. So this can help to smooth out the supply of solar energy and make it more reliable and predictable. So when we can present some of the specific benefits of using energy storage solution to optimize solar energy uses. So first, we can discuss about increasing self-consumption. The energy storage solution can help to increase the amount of solar energy that is consumed. This can help to reduce the dependence or the reliance on the grid and save money on electricity bills. So second point is reduce the energy cost. So energy storage solution can help also to reduce the energy cost by allowing to take advantage of time of use pricing. So the time of use pricing is a billing structure that charge different rate for electricity depending on the time of the day. So by storing solar energy during off-peak hour and discharging it during the peak hour, it can avoid paying the highest electricity rate. Let's present two cases, for example, or two examples regarding commercial uses and utility scales uses. For commercial and industrial solar energy storage system are becoming more common. So this system can be used to store solar energy generated by the business and the factory and use it to power their operation during the day and the night. And for the utility scale, the storage system are the largest type of energy storage system. This system can store solar energy generated by utility scale solar farms and use it to power the grid during time of peak demand. The third point is improving grid stability, as Mr. Tamer and Mr. Hudhaifa said or highlight. So the energy storage can help to improve the stability of the grid by balancing the supply and demand, since the solar energy is intermittent, as I said before. So this can help to prevent blackout and other power outage, and can help also to establish the or to reduce the fluctuation and establish and get stable voltage for the grid. So the third point is reduced environmental impact, which is the most important point. It can help to reduce the environmental impact of solar energy by reducing the need to rely on fossil fuel or conventional power plant. By consequence, it will reduce the greenhouse gases. So we are discussing about solar, about energy storage, but there is a different energy storage technology available in the market, including battery, pumped hydro storage, flywheel, and green hydrogen or ammonia. So the best energy storage technology will depend on your specific needs or your specific application and requirements. Thank you. The floor is for you, Mr. Hassan.
Thank you, Mr. Yahya, for your inputs. Of course, as you said, energy storage is very crucial in the sustainability of production of energy to consumers. And as you said, ammonia or green hydrogen is one of the method that, to store energy. And actually, what we can see that after the Ukrainian-Russian war, more needed green hydrogen issues have been raised. So maybe, as we said, that we need to know more about desalination of water, because green hydrogen will need fresh water. Egypt is scarce of fresh water. So maybe Mr. Ayman, I believe you have provided some information within your words. So maybe if you can elaborate more on this issue, how it will be in the future, if really the 23 MOUs go on implementation, how much energy we need for desalination of water to these plants. Mr. Ayman,
Thank you, Hussam. Thank you for reading this point. It will be some of integration between the water desalinations needed for the green hydrogen. First, for generation of hydrogen itself, and the cooling system for the equipment. As we know that Suez Canal Zone, it will be a host generation facility for the hydrogen in المنطقة الاقتصادية, the economic zone in عين السخنة, and they provide more than 30 kilometers square to erected the facility by each developer. But regarding the common facility can be shared from the authority itself, the main important to erected multi-phase of desalination water from the Red Sea source. It's something like 1 million meter cubic per day for the futures, starting with 250, just to covering the what you call the pilot project and phase one. The green hydrogen, it's make like to mature this technology and to be adequate, a realistic step to erected, as I say before, 44 giga electrolyzer aim to be installed by the end of 2030, 2032. That's mean 10 years later. The water which needed something like 500 meter cubic per day in nearest future, 2026 or 2028, something like that. Just to keeping the green label for the green hydrogen, as you know, and the others should be aware about the energy itself, the source of energy to running or to feed the RO plants, it should be from the renewable energy for the two issues, the labels, and second for the cost of the generation. If we use the traditional energy to feed the water, it will be expensive, and also something to affect the color of the hydrogen back to blue or others. So both of them, from enviro and economic, it should be renewable energy. That's mean the more potentials for the solar and wind to be feeding this system for green hydrogen generation and water. Uh, that's all in this.
Thank you, Mr. Ayman. And this shows how the market will grow. It's not only growing for providing electricity immediately, but also for storing the electricity, as Mr. Rahi and others were discussing this issue. And of course, it's very it's very crucial to know the environmental aspects and the requirements for such type of activities. I think now
Let me add
we
here another
yes.
statement. One statement, just in Aquapower in KSA, we start our project for generation green hydrogen there with a total capacity 4 giga for renewable energy, more than 1.25 million ton of green ammonia by the end of 2027. Already we financial closure this project was 8.5 billion dollar. So Aquapar working hard working to decarbonization and the fuel transitions from the traditional fuel to be uh, hydrogen or carrier of the hydrogen, green ammonia. So we aim to repeat this successful story in Egypt, inshallah, in nearest future.
Inshallah. Thank you for this positive information, because
Be
we
welcome.
always look at this issue as it's job generation, it's fulfilling gaps or future gaps in energy consumption. Hopefully that we came on time with 2 minutes just from our time for the question and answer session. I believe we have like two interventions. Grant is providing, I don't know this question or like want to some of the panelists to elaborate on it. Preventive maintenance, warranty follow-up, and scrapping at the end of life, and customer satisfaction. These issues, maybe one of the panelists or any of you would like to provide such feedback for these issues, especially the end of life. This is we need to close the loop. This is we always talk about this. So if end of life is a major issue in 10, 20, 30 years, how this will be done. So if anyone would like from the panelists to respond to this intervention from Shukri. Maybe Mr. Huzaifa, do you have input for this issues, preventive maintenance and warranty follow-up and scrapping at the end of customer satisfaction? Please do if you have.
Hello. His question is not clear, but preventive maintenance for the storage. Regarding storage, we are providing now 10-year starting warranty for the storage system. Lithium batteries, inverter can be extended up to 20 year. This is standard warranty, and preventive maintenance can did by any approved EPC or installer. It is very simple and can monitor it by the software, the performance of the storage and inverters, so we can know if there is any deviation from the number that we have to get from the solar panel, solar planets. And also there is in that time there is many monitoring system help us to diagnose and see how the inverter and storage doing for more better performance. So there is high standard warranty starting from 10 year up to 20 year, and there is preventive maintenance from the installer. So I think yani, it is high old for the systems that can ensure that the investor or the who need the power can get it for a long and as bare quoted from the vendors.
Thank you, Mr. Hudayfa.
Also,
Anyone
I
of the
want
panel?
to highlight one thing, Mr. Hussam. Now we will face more demand, and we will there's be more demand for the solar and energy storage. You know, the panel prices is drop in dramatic way, more 50% down, and the lithium prices also go down. This make the solar storage and solar planet more visible and more economic comparing with others maybe power sources. This is will be added value for the solar in the next, let's say, 1 or 2 years. The price is now in bottom, very low price with high quality, and never reach this level of the price that push up, push and boost people to go with the solar industry that in this time of the, let's say, for their power sources. Thank you.
Thank you, Mr. Hudayfa. Maybe we'll, if any of the other panelists would like to share information or provide insight about these issues, warranty follow-up, scrapping, customer satisfaction, or we can go directly to the next intervention from Iman. I think she's saying that is it possible to build a solar plant solely for water electrolysis for hydrogen production? Mr. Ayman, I think you can provide some insight about this.
Yes, shukran, Hussam. Let us talk from the what you call from the end of the process. If we are looking for the successful of energy transition, that's mean we needed to look looking for the energy with the low cost and competitive process to achieve this transition. That's mean for the feeding the electrolyzer with solar, it will be something like a short period of the daylight time, 8 or 10 hour per day, feeding the system. That's mean we needed additional storage, a huge storage to be keep it running for 24 hours to process and to complete the process per day of the hydrogen generation. So we don't agree to only solar. The solar and wind can be achieved like what you call the base load, daily base loads can be achieved by wind and solar, and putting a very small storage system, battery PSS, it can be used to be what you call the emergency and to keep it the system running only, not to generate, just to keeping the system and the critical process should be have the power. So the overlap between the wind and solar, it is the best match until now to generate the hydrogen. I hope this answers the question.
Anyone of the panelists would like to add for this question? If not, more questions. I think that we have only two and we have intervened. So I would like to thank all the panelists for their knowledge and sharing of information that they provided with us. I think we were still in the beginning of the trip for having solar energy plants. As we can see in the coming future, it's totally different than what we have now. Thank you very much, and I will give the floor to our organizers, Ms. Periyanshi. The floor is yours. Thank you. Thank you.
So, a big thanks to all our esteemed speakers for this wonderful session. We once again to remind everyone to join us on 23rd October in Cairo and witness an engaging discussion with the biggest solar experts in Egypt. To take a look at the event details, please click on the link shared by my team in the chat box and visit the website. So, thank you all the audience and panelists once again. So, with this, we have come to an end to the virtual event, and a very special thanks to Mr. Hossam for superbly managing the session, and a big shout out to the attendees for extending their time and support for the event. So we promise to come back soon with another exciting virtual session. We look forward to hosting you on the physical event on 23rd October for the Solar Week Egypt conference and awards. The registration link for this is mentioned in the chat box, and the floor is now open for networking. Thank you so much, everyone.
Thank you all. Have a good day.
Thank you.
Thank you all.
Thank
Thank
you.
you. Thank you, Mr. Hassan.
Thank
Thank you.
thank you.
Thank you.
Bye, everyone. Take
Bye.
care.
Thank you, Yahi. Thank you, everybody. Thank you.